welcome to this technical video. The topic is related with isolator, switch and circuit breaker. Before entering the topic, let me introduce myself. My name is James Kuti Thomas, retired electrical inspector from Kerala. Through this YouTube channel, I like to share some technical informations based upon the rules and regulations that we have. With implementation, there are still many confusions about the correctness what we implement. The main reason for this disparity or the confusion, I understand, is the language of our rules and regulations. The technical informations are expressed in the legal way, I must say. But this is the only way and the language to express the statutory standards. But then we must extract the actual technical meaning what we want to follow. In this video, I like to discuss about the differences of isolator, switch and circuit breaker. What's set with our regulations and BA standards about their requirements and implementation. Throughout the video, I quote the statutory references of the topic. I am not there to deviate anything from what's said with our laws. The topic is little bit lengthy when we compare with YouTube time. So I am splitting the whole topic into different videos or parts. If you find this video useful, please share with others and also please subscribe my YouTube channel and support me. Let us move to the topic. Okay, let us start the topic. Isolator, switch and circuit breaker. What is their difference? Here in the topic, I am taking the references from Safety Regulations 2010 and the Indian Standard 732 and 60947 and then National Electrical Code. Some of the basic terms I am dealing with in the topic is point of commencement of supply, fuse, cutout fuse, isolator, disconnector, switch, circuit breaker, RCCB, then RCBO, residential current circuit breaker with overload protection, pole, overload, short circuit, earth fault and earth leakage, then neutral link and switch gear. Here you can see two connections, one is 3-phase and the other one single phase. One 3-phase meter is shown and below that 3 cutout fuses. Then to the other side single phase energy meter, then on single cutout fuse, then you can see neutral in both sides. Now the consumer part is also shown. Here the breaker there is zoomed here and you can see on the MCB and RCCB. I am asking whether these connections are correct or not, whether the connections to the supplier side or consumer side, whether it is correct. For entering into that topic, let us deal with some basic terms. The first one is point of commencement of supply. As per Regulation 16.3 of the Safety Regulations, the point of commencement of supply of electricity means the point at the incoming terminal of the switchgear installed by the consumer. Here you can see on supplier side and the other consumer side. To the supplier side on energy meter is shown and cutout fuse, and to the other side on main switch linked switch fuse. And here the point of commencement of supply is the point at the incoming terminal of the consumer switchgear. And see here the highlighted portion is carrying the point of commencement of supply, and the exact point is at the incumbent terminal of the consumer part. And here the highlighted portion is carrying the commencement point of commencement supply, here also shown. Now we need to understand whether the connections shown are correct or not. That we can take later. Before that, let us move through some switchgear basic terms. Okay, the first one is fuse. As per IS 732, what is fuse? We all know fuse means it will blow or melt when a high current or the current beyond a limit is flowed. Then it will fuse itself and it will protect the circuit. See that as per the definition, a device which by melting of one or more of its specially designed and proportioned components opens a circuit in which it is inserted by breaking the current when this exceeds a given value for a sufficient time. Here the revariable fuse is shown on the right side, and to the left side high rupturing capacity fuse or HRC fuses is shown. Here I gave only a basic definition of fuse. Fuse itself is a vast topic to be discussed, but I am taking on the basic term. Now next term is isolator or disconnector. Both are having the same meaning. We can use the terms independently as per IS. What is isolator or disconnector? It is a mechanical switching device. Mechanical switching device means it can be made on or off. So isolator means it is a mechanical switching device. In the open position, when the isolator or when the mechanical switching device is in the open position, it should comply some requirements which are explained below. Means actually, what is isolator? Suppose we are having a water pump in a remote area. We need to have one isolator there for doing some maintenance in the pump. So when we off the isolator, we can see the supply is off there. Means we can see the circuit is opened there. We can visibly see as it is opened, and the isolation is guaranteed there. Okay, that is the requirement. When on device is said to be isolator, we should get to the guarantee that the circuit is isolated. Okay, what are the requirements for isolator? As per the first clause, it can be made opened or closed with negligible current or no current, or no voltage in between the terminals. Means it can be operated, or the isolator can be operated only in off condition, means when there is no supply. So the purpose of isolator is to operate when there is no supply. Okay, that's the first condition. And to the second condition, when the isolator is in on condition and the circuit is also on, it should carry the load current. Means it should be able to, isolator should be able to carry the current, carry the load current, and also the abnormal currents such as overload or short circuit current, that also should be withstood by isolator for some specified time. That is the second condition. See here, on conventional type isolator is shown. When the lever is operated, we can see the circuit as opened, means the opening is visible. See the third condition here. In this isolator, in this conventional type, we can see the terminal, we can see the opening as visible. But in case of MCB, or in the case of circuit breaker such as MCB or MCCB or some others, there we can't see the circuit as visible. The opening cannot be seen as visible. So in such cases, as per this IS, some other adjustment is enough. What is the other requirements? there must be some indications off or on. Means it can be written as off or open, or it can be represented as O or I. Okay. Suppose in case of an MCB, if it is shown as off or O, that means the circuit must be opened. The meaning is, inside that device, the mechanical, that portion is a single piece. Means it will be moving as a single piece. So if it is showing off, it is certainly off. Means we are getting the guarantee that the circuit is off. You please read this underlined portion. Such indication shall only occur when the isolating distance between open contacts on each pole of the device has been obtained. Means that display of on or off will be coming to our eyes only when the terminals are opened. That's the meaning. So instead of the term visible, the indications such as off or open or O or I is enough as per this IS. Okay, that is isolator. Now we are moving to switch. Switch is similar to isolator, except isolator can be operated when there is no supply, but switch can be operated even if there is supply. Means it is also a mechanical switching device, but it must be able to make the circuit or carry the current, load current, or carry the current and breaking the current, and also it should withstand the abnormal current such as overload or short circuit current. Means in the case of isolator, it is not said that it should break the current. Means it is actually not breaking the load current. It is not the purpose. But for switch, it is the purpose. When the current is flowing through the circuit, we can operate the switch. That's the difference between isolator and switch. See the note under this definition. A switch may also be capable of making but not breaking short circuit currents. Actually, switch itself will not protect a circuit. Suppose in the conventional type of switch, we will be adding on fuse there. So it will be called as switch fuse. Then the fuse will protect the circuit. That is what means there. Switch means it is intended to operate when the circuit is carrying current. Means it can be operated when there is current. But isolator, it is intended to operate when the circuit is not carrying current. It is used to isolate a circuit or equipment from a source of power. Means its purpose is to isolate. Anyway, we will go in deep about isolator, and some other requirement also will be discussed later. Now next basic term is circuit breaker. Isolator, switch, and then circuit breaker. Circuit breaker means it will off when there is abnormal current. Off means it will trip itself. That's the meaning. Circuit breaker will trip itself when there is abnormal current, such as overload or short circuit. It will operate automatically. See the definition here. It is also a mechanical switching device capable of making, carrying, and breaking currents under normal circuit conditions, and also making, carrying for a specified and breaking currents under specified abnormal circuit conditions such as those of short circuit. Anyway, circuit breaker means it is something like a switch, but it will Switch will not open automatically, but circuit breaker will open automatically. But it will not close automatically. Circuit breaker will not close automatically. To make it automatically close, we can make it motorized. See here, mechanical switching device capable of making, carrying and breaking normal currents. That is common. But for the overload, which may include specified operating overload conditions and also of carrying for a specified time currents under specified abnormal circuit conditions such as those of short circuit, means both are having somewhat similar definitions, but still there are some differences which will be discussed later. Please note these notation symbols also. These are the standard symbols we are using. Actually, we will go in deep about these symbols also. Now, to understand some details of the switchgear, we should know what is overload and short circuit. See, overload means current is going beyond a limit. See here, one motor is shown which is fed through, supply is fed through an MCB, and overload means when the current goes beyond a limit, it will automatically trip. See here, C32 means 32 ampere current. Its capacity is 32. Or the current motor can carry up to 32 ampere. So when the current goes beyond 32 ampere, it will trip. If the current going beyond 32 ampere, that is what is called overload. Means the load is having a rated load current. When the current exceeds that current is called overload. Then short circuit means getting shorter. Means suppose phase to phase may be shorter or phase to neutral may be shorter, then a high current will flow, and it is what is called short circuit, and the rating of the current may be kilo ampere. That is what is called short circuit fault. Okay, next is earth fault and earth leakage. Actually, both are entirely different faults. Earth leakage means in the range of milliampere only. Suppose some insulation failure or some leakage to this motor, means from this phase conductor, current may be flowing through this earth in just like leakage. Means suppose leak in a water pipe. Like that, there may be a leak in this electrical circuit also. That is actually what is called a leakage or earth leakage. But earth fault means that's a different one. When a phase conductor touches directly the earth conductor, okay, then a high current may be flowing. That is what is called earth fault. That is the difference between earth fault and earth leakage. For earth leakage, protection of earth leakage, we can use earth leakage circuit breaker or RCCB in our residential buildings. And see here the note also, circuit breaker will be rated in A for overload protection. This protection is achieved through thermal tripping, 32 ampere. We will be dealing with the thermal tripping and magnetic tripping later. And here the rating of the MCB shown is 32 ampere. Then short circuit in the range of kilo ampere. Then about earth leakage protection, we can use RCCB. Actually, RCCB can be used up to, RCCB itself is having a rating, not a leakage current rating, the other load current rating, and up to 63 and I think up to 63 ampere we can get RCCBs, and beyond that suppose we need to use it for 125 ampere. In such cases we can use an MCCB with CBCT ELR arrangement. Anyway, for this topic we need to understand what is overload and what is short circuit. In the breaker, we can get in this MCB, we can get overload and short circuit, but for earth fault and earth leakage, some other arrangements should be done. Now, let us see the difference between switch and circuit breaker. See, switch can be operated only manually, but a circuit breaker will break automatically, what is called a tripping, but may not be automatically reclosed. It can be made automatically operated by making it motorized. By adding a fuse with switch, it will act as a switch fuse unit. Then the fuse will melt during overload or short circuit. That's the basic difference. Next is making and breaking. Making means making on the circuit, and breaking means breaking the circuit in abnormal condition, means just like a short circuit. So for switches and circuit breaker, switch will have making current only, but for circuit breaker it will have both rating, making current rating or making capacity and breaking capacity. Making capacity in the range of ampere and breaking capacity in the range of kiloampere. That is explained here. There are two important parameters concerning the connection and disconnection of power for electrical utilities. Making capacity, the maximum load current at startup. When the circuit is made on, the current flowing, immediately flowing is the starting current. That is the making capacity. And breaking capacity means the current at the abnormal condition, the maximum fault current that can be interrupted. Circuit breaker designed and is rated for both making and breaking fault and load currents. Switch designed and rated for only making and breaking load currents. Means switch is designed for carrying, making, switch is rated for making load currents and breaking load currents. Means switch can be used to break the load current, but not to break the abnormal current. Means at the abnormal current, the switch may not operate, but the unit, switch fuse unit, that can withstand or that can have a breaking capacity, means kiloampere capacity. Anyway, a circuit breaker is having both the ratings, making and breaking capacities, but switch is having only making capacity, means making load current or breaking load current. But when the switch is incorporated with the fuse, it can have the breaking capacity also, means kiloampere capacity also. Means switch fuse unit will have kiloampere capacity, means it can withstand kiloampere currents. Okay. Now we are moving to the next term, poles, number of poles. See here, in the first picture I have shown a switch here, which is having the phase connection only. Neutral is fed directly and the phase is having a switch. Means it is single pole, means it is having only one circuit or one phase. See here I have shown on MCB and the normal switch. So these two are of SP, single pole, and the next one DP, double pole, means it is having two poles or two circuits. Phase is also having a pole and neutral is also having a pole. So both poles are double poles are there, and I have shown the picture also on switch for residential purpose. DP switch is shown here, and the other one MCB DP MCB is shown here. For this DP, all two poles are protected. Means when phase current is exceeded a limit, that will be protected, and the neutral pole is also having protection in the case of this MCB only, not for this one. Okay, next is TP, triple pole, means three poles are there, all the poles are all the 3 poles are protected, and I have shown on 3 pole MCB here. Next is SPN, single pole neutral, means this phase pole only will have protection, but neutral will not have protection. But when it is breaking, it is linked. See, both the poles are linked, so it will operate together, but the protection is only for the phase pole. See here the MCB here for the isolator, for the neutral part it is shown as red. Next is TPN, triple pole neutral, means it is having 4 poles, but the neutral pole is not having protection, but it will work together being linked. Next is 4 pole, means 4 poles are there for 3 phases, and on neutral all the poles are protected, and it is used for generator or emergency circuits to isolate all the terminals, means all the 3 phases and neutral will be isolated for protection. In such cases we can use 4 poles. Okay, next term is linked switch or linked circuit breaker. What is mean by linked switch and linked circuit breaker? Here, please go through this figure. Here, all these poles are linked, means when this lever is operated, all are operating together. Similarly, in the case of on road is inserted here for this MCB, and all the poles will be operated, and it is shown here. This MCB is TPN, means N is having linked process, but it will not have protection. Anyway, I think meaning of linked switch or linked circuit breaker is now clear to you. Next, I am going to National Electrical Code, some basic notations we want to go through. Switch, see, it is the representation for switch. Next is isolator representation, and fuse and circuit breaker. Next, depending upon the function, I have shown 3 sections. One is switch, one is disconnector, and the other one is switch disconnector. Please note these numbers 1 and 2. 1 means the incoming part, 2 means the outgoing part. See, switch, I already told you switch, what is switch. Then disconnector or isolator, that is also I told you, to isolate the circuit. But what is switch disconnector? It is having the property of switch and disconnector. What is called switch disconnector? Switch means to operate when there is supply. Disconnector means to operate when there is no supply. But disconnector or the isolator is having the guarantee that the circuit is isolated, or we can say technically it is having isolation duty. Okay, so what is switch disconnector? Switch disconnector is a switch having isolation duty. That's a difference. Okay, now depending upon this combination, fuse with a switch or fuse with a disconnector or fuse with a switch fuse disconnector, we can divide these devices into different categories. One is switch fuse. Switch fuse means firstly switch is coming, then fuse. Then disconnector fuse means first disconnector, then fuse. See, please note these numbers 1 and 2. Then switch disconnector fuse. First switch disconnector will come, then fuse. Now here in this category, these 3 category, fuse is moving along with the switch or isolator. So here the current will be current flowing will be completed first in fuse. So it is called fuse switch, the last one, fuse switch. Then fuse disconnector. Fuse is clubbed with disconnector. Fuse disconnector. Next is fuse switch disconnector. That's a difference. Fuse, switch, disconnect. In this IS 60947, the definitions for this switch disconnector, switch fuse, etc. are given, and please note these notations. I shall read this one. Fuse disconnector FD is a disconnector in which fuse link or fuse carrier with fuse link forms the moving contact. Means with the moving contact, the fuse also will be incorporated and the fuse will be moving along with the switch movement or the isolator movement. That is what is called a fuse disconnector. You please read this section. Now I have shown some actual images to understand what is switch disconnector, fuse or SDF or SFU, etc. You please go through that one. Now fuse disconnector, fuse switch disconnector, fuse switch disconnector. Means here you can see that fuse switch disconnector means fuse is moving along with the moving portion of the switch disconnector. See here, the definition of switch gear as per this regulation and IS 732. What is switch gear? Actually, switch gear itself is a term, a basic term. Switch gear means what we studied so far: isolator, switch, circuit breaker, or whatever it is controlling the circuit is called switch gear. See the definition here. Switch gear shall denote switches, circuit breakers, cutouts, and other apparatus used for the operation, regulation, and control of circuits. The same meaning is there for 732 switch gear definition also. An assembly of main and auxiliary switching apparatus for operation, regulation, protection, or other control of electrical installations. Actually, somewhat the definitions are same. Switchgear is an apparatus used for operation, regulation, and control of electrical circuits. It can be isolators, switches, circuit breakers, cutouts, or any other apparatus. I must say, even the bus in a switchboard is also a switchgear. I have seen such a definition. That is why I am telling. Okay, that is what is switchgear. Now the next portion is discussion about the connections or the switchgear in the supplier part and the consumer part. What are the switchgears required there as per our regulation, and that we can discuss later. So far we've gone through fuse, isolator, switch, circuit breaker, and I have explained the differences and what is the purpose of isolation and how the isolation can be guaranteed and what is meant by isolation duty and what is making capacity, what is breaking capacity, and switch is having only the making capacity, not the breaking capacity, and circuit breaker is having both definition, both current ratings, making capacity and breaking capacity. Making capacity in the rating of ampere and breaking capacity in the rating of kiloampere, but switch fuse is having the breaking capacity. And anyway, I am stopping this part. Please share this information with your friends if you are finding it as useful, and also please subscribe to my YouTube channel, and let us see in the next part. Thank you all for your patient listening. We can see later. Thank you.